Half subtractor is the digital circuit which performs subtraction of two 1-bit numbers. The first 1-bit number is A, the second one is B, and this will perform A minus B operation. The result will be difference and the borrow generated after performing the subtraction. Let us look at the truth table of this half subtractor. A and B are the inputs and four possible combinations of values of A and B are shown here. Now when A minus B is performed, that is 0 minus 0, first row, it will give you difference as 0 as well as borrow is 0. 0 minus 1, smaller number minus larger number. In this case difference is 1 and borrow will be generated. So borrow will also be 1. Third row, 1 minus 0, difference is 1 and there will be no borrow. And last row, 1 minus 1, difference is 0 as well as borrow is also 0. Now let us find out the expression for difference by using the K-map. So we'll just concentrate on this difference column. As number of inputs are 2, that is A and B, a 4 cell or a K-map of 4 square is required. A is written here whose values can be 0 or 1, that is A bar A. Similarly, B is written here, B can be 0, which is also called as B bar. B can take a value of 1, which is B. And the output values, that is the difference values, they are written inside the box. In first case, when A is 0 as well as when B is 0. A is 0 and B is 0. In this case, the difference is 0. So A is 0, B is 0. In this case, difference is 0. So 0 is written here. In second case, A is 0, B is 1. A is 0 and B is 1. Means in this cell, the difference is 1 and this is written here. In third case, A is 1 and B is 0. A is 1 and B is 0. So we will enter the values here. And what is that value? Difference is 1. So 1 is entered here. And the last case, when A and B both are 1, difference is 0. So when A and B both are 1, difference is 0. Now we have to derive the expression by looking at the K-map. There is no possibility of forming the group of 4 ones. 2 ones are there, but they are diagonal in nature. So we will just have 2 independent ones. So let us encircle the first one and find the expression corresponding to it. Look at the left hand side, it corresponds to A bar. Look at the top side, it corresponds to B. So the product term is A bar B. Similarly, the second one is here, encircle it and write the expression for it. Look at the left hand side, it corresponds to A. Look at the top side, it corresponds to B bar. So obviously the product term is A into B bar. So these product terms are added together and they are written in SOP form. So difference is A bar B plus AB bar. And when you recall the knowledge of universal gates, then this A bar B plus AB bar, sorry, not universal gate, special purpose gate, this A bar B and AB bar is the expression for A XOR with B. In short, to generate or to implement the circuit for difference, I will require one XOR gate whose inputs will be A and B. Let us move to the second K-map, which will give you the expression for borrow. So the borrow K-map will have the same size because A and B are going to be the same values. The difference is that we will take this set of value, that is values written below the borrow column. When A is 0 and B is 0, that is first column, A is 0, B is 0, borrow is 0. So borrow is 0. When A is 0 and B is 1, A is 0, B is 1, the borrow is 1. So borrow is 1 is written. The third case, A is 1, B is 0. A is 1 and B is 0. So it intersects here. And what is the value of borrow? Borrow is 0. And the last case, when both A as well as B are 1, the value of borrow is 0. So value of borrow is 0 is written here. Now let us derive the expression for borrow. A single one exists, so encircle it and find the expression. Look at the left hand side, it corresponds to A bar. Look at the top, it corresponds to B. So obviously the expression is going to be A bar B. So borrow will be A bar B. To implement this half subtractor circuit, what I have to do? I will require a help of one XOR gate one NOT gate to convert A into A bar, and A bar into B will be realized by using one AND gate. And this shows the diagram of half subtractor. This XOR gate whose inputs are A and B will give you difference, and this AND gate whose inputs are A bar, because A is not directly fed to AND gate, it is connected to NOT gate, so here it will be A bar. B is directly fed to second input of AND gate, so it will be B, and obviously the output of this AND gate will be A bar B, and this will give you borrow. So in short, one XOR gate, one NOT gate, and one AND gate will help us to realize, to implement half subtractor circuit. Thank you.